Hello, here in this video we're going to look at something called the percent proportion. Every number is a percent of some other number. Percents link all numbers. If you can understand percentages, you can navigate all numerical changes. Times where we use percent changes. The most major one that you've probably come into play with is sales, when things could be something like 30% off. Leaving a tip at a meal, where you need to leave 20% of a tip. Or maybe you've purchased something expensive, or maybe you wanted to buy something that was used, and it's worth less than it was initially, right? Anytime you're purchasing something for less money than it initially cost, or maybe if it became a collectible and you're buying it for more than it initially cost, that is the percent proportion. Here is the key to all percents. We saw that all numbers, so I'm going to say A is equal to B here. I'm going to leave that space there in front of it. All numbers are linked by some percent. And when we're dealing with percent, we're using multiplication. So all numbers are linked by some type of percent. And you could set this up to where A and B could be different variables. I'm just picking A and B as two numbers. Whatever A is, and whatever B is, you can then find some percent that links them. Now, you're going to see some words down here, such as of. You might see this word of some. You might see this word is. Of what number. These are going to be common phrases that are used with the percent proportion to help us understand how we set it up. And then one final piece of information is this. If we're given a percent, I'm going to say 50%. We don't use percent signs in our calculations. Instead, we need to convert it to a decimal. To convert a percent to a decimal, you divide by 100. So 50% in a mathematical realm is 0.50. 0.50 represents 50%. Now, if I needed to take 50% and express my answer as a percent, we undo the division of 100 by multiplying by 100. So dividing by 100 goes from percent to decimal. If you want to go from a decimal to a percent, you multiply by 100. And the non-calculator shortcut for this is to move the decimal place. Dividing by 100 moves the decimal spot 2 times, which is how we end up getting the 0.50. When you multiply by 100, so here we divided by 100. If you multiply by 100, you move the decimal 2 spots to the right. And that can help you navigate percents even if you don't have a calculator, because essentially all we're doing is moving the decimal. So here are some additional words. This multiplication is going to represent the word of. The equal sign often relates to the word is. Using those two words can help us set up these problems. So let's do some of these you-tries. So it says what percent? That means as far as it goes for us using the equation here, we are looking for, when it says what percent, this value right here. Right, and we can use a variable to help represent it, right? We could say for all the problems down below, we could use, percent, we could just substitute it out for x, right? Where x is going to represent our percent. So it says what percent? That means we don't know what it is yet. We're looking for that value x. When it says of 90, that of means multiplication, right? We see it right there in red. The of means multiplication. So when it says of 90, that's multiplying by 90. because of means multiplication, and is the equal sign. So when it says is 54, we place it just like that. Now, when we're solving for variables in this situation, I know we haven't gone over solving equations yet, but these do all become one-step equations to where if x is multiplying by 90, we're going to need to divide both sides by 90. And when we do that, I'm going to go ahead and type 54 over 90 into a calculator and get 0.6 is equal to x. Now notice that the question said, what percent? That means we need to turn that 0.6, or if you want to think of it as 0.60, back into a decimal by moving the decimal place over 2 spots, and we'll get the answer of 60%. And it's often helpful to go back and write out the full equation and see if it makes sense. It's saying that 54 is 60% of 90, right? And that makes sense mathematically because 60% of 90 is going to be a smaller number, and 54 is that number. So let's try one here for you. So see if you can get this one set up. What percent of 40 is 25? Use the previous one as an example and see if you can set it up and solve. So to set this up, I'm looking for a percent, so I'll label that as x. It says of 40 is equal to 2.5. Now, I'm expecting x to be a small percent because 40 is much larger than 2.5. So when I go and I divide both sides by 40, I get 0.0625 is equal to x. And then we need to move that decimal spot 2 spots over. So the answer for this one is 6.25%. And that makes a lot of sense mathematically because if I'm trying to reach 2.5 and the number I have is 40, it should make sense that my percent has to be very small. 0.0625, which is 6.25%. Now, this equation here has 3 parts to it. It has A, it has percent, and it has B. So that means there's going to be 3 different types of setups. Some where our answer is going to be a percent. Some where we're looking for a specific number. In this case, when I see the word is, I know I'm going to be looking for my A value. And then there's going to be some where it says of what number. So that's going to be when we're looking for that B number. So for this one, it says what is, so the number that we're looking for is on the equal sign, 32% of 125. And there's really no solving needed on this one because we're able to just go ahead and do 0.32 for 32% times 125 to get that our value here is 40. 40 is 32% of 125. And that should make sense logically because 32% is almost a third, and almost a third of 125 is around the value of 40. So try one here. What is 35% of 80? So we have 35% of 80. And we're looking for our is value, which is an A. And when we get an answer for that, it should be 28. All right, 35% of 80 is 28. And then finally, we're looking for the of what number. So in this case, 125%, when I divide by 100 and move that decimal spot over, we get a value of 1.25, and it says is 17.5. So to solve this one, we will need division again. We'll divide both sides by 1.25, and when we do that, we get a b value of 14. And this one should make sense too. Now 125% means the number is going to get bigger. So 125% of 14, 14 is going to grow, and the number it grows to is in fact that 17.5. So that would be an example where something maybe gets more expensive because it gets popular or becomes a classic item. Sometimes things are worth percents above 100% because 100% of its initial value means it stayed the same price. 125% means it has gained in value by 25%. So take a look at this one. 30% of what number is 12.5? 30% of what number, so of b, is 12.5? And we'll use division to help us find that. To get that our b value here is 41.66 repeating. Now, one thing that we'll cover is that we typically don't use repeating decimals. We'll more or less use fractions to help us express scenarios like this. But I haven't covered that with us, so in this case, it would be appropriate to just leave it as 41.66 repeating. We can check out the remaining problems as well as the word problems when we're back together in class.